Welcome to all of you. Now we discuss about Lagrange's interpolation problem 14 numerical practical by C programming semester 6 CBCS B.Sc honors in mathematics University of Calcutta. And this is the Lagrange's interpolation problem 14. Write a C program to compute the value of fx at 0.79 plus r plus 1 divided by 1000 and at 0.98 minus r plus 1 divided by 1000 by suitable interpolation formula from the following table. X is 0.75, 0.79, 0.85, 0.93, 0.98, 1.05 and corresponding fx are 1.147347 and so on, so on, so on, where r is the last digit of your C roll number. Here notice that this x0 this 0.75 and x1 is 0.79, so difference is 0.04, and this x1 is 0.79 and x2 is 0.85, so difference is 0.06. And so here we use the Lagrange's interpolation method because the interpolating points the x0, x1, x2 and x3, x4, x5 here not necessarily equispaced. We know that interpreting points xi need not necessarily be equispaced for this Lagrange's interpolation method. So we use here Lagrange's interpolation method. But note that Lagrange's interpolation method may be used for unequispaced and equispaced both. Here the float variable x is one-dimensional variable. This from x0 to x19, say 20. Y is one-dimensional variable, array variable, one-dimensional array. This y20 in memory location y0 to y19, and d is d20 sum w xx is the one-dimensional array. Here 10 values xx, xx0 to xx9, and integer variables are n, I, k, j, and r. First, enter the value of r. This is the last digit of your C roll number. Now here the interpreting points are this 1, x0, x1, x2, x3, x4, x5. So interpreting points is 6 here. So n equal to 6. Put n equal to 6. The interpreting points xi, this x0, this x1, x2, x3, x4, and x5. And the values of fxi, that is yi, that is y0, y1, y2, y3, y4, y5, according to our problem. And this we give this, write this here, and the values of xi for which the interpolation is required. We note here from distinguish x, so we write here xx0. This is the x, this x for this x, this 0.79 plus r plus 1 divided by 1000, and this x 0.98 minus r plus 1 divided by 1000. I call it xx0 and xx1. So we write here xx0 this and xx1. Now calculation is this. This k is the number of xi for which interpolation is required. So here we find for two values of x, this xx0 and xx1. So we write here k equal to 1. K actually starts from 0 and k equal to 1. This is the k equal to 0, xx1 and xx2, for which we determine the value of corresponding yi. This. Now for I equal to, for k equal to 0, for first point, this xx0, I want to determine the value of fx0 for this xx0. So for I equal to 0, I less than n, I plus plus. So I starts from 0 to I less than n here 6. So I equal to 0, 1, 2, 3, 4, 5. So this di equal to 1. So what is di? And this is the Lagrange's interpolation scheme for 5 plus 1 interpolating points according to our given problem. Here this x0, x1, x2, x3, x4, x5. There are 6 points, interpolating points xi are not necessarily equispaced for Lagrange's interpolation. The formula is that L5x, this 5 means the actually this notation is used here, this L5, this Lagrange interpolation polynomial L5 is of degree at most 5 and for 6 interpolating points. Here 6 interpolating points, so degree of this Lagrange's interpolation polynomial at most 5 degree polynomial, and which is unique. This is unique, and this is the wx and the summation yi by di, I equal to 0 to 5. That is wx equal to y0 by d0 plus y1 by d1 plus y2 by d2 plus y3 by d3 and so on, so on. Where wx is the x minus x0, x minus x1, x minus x2, x minus x3, x minus x4, x minus x5. And this x is for this here we call it this x60. This x60 is this here, x here, x here. And d0 is the x minus x0, x0 minus x1, x0 minus x2, x0 minus x3, x0 minus x4, x0 minus x5 into. And note that this first term in d0 is x minus x0, and from the next term x0 minus x1. So this is the d0 and this d1, this x1 minus xi. Only difference is this x1 minus x1 not. This is replaced by x minus x1, or d2 replaced by x minus x2, and other factors are x2 minus xi. Only x2 minus x2 replaced by x minus x2. And similarly for d3, the factors x3 minus xi, and only the factors this when I equal to 3, x minus x3. d4 is this and d5 is this. So you can easily calculate this d0, d1, d5 and this wx here. So this is the di, that is d0 initially value d0 equal to 1, and for j equal to 0, j less than n, j runs from 0, 1, 2, 3, 4, 5 up to 5 here because n is 6 here. If j equals to I, di equal to di star xxk minus xi. Initially I equal to 0, so d 0 equal to 1, j equal to 0, so this if j equal to I, j equal to, so here 0 I equal to 0 equal to j, so d0 equal to the previous value d0, that is equal to 1 into xxk. Here k equal to 0, so xx0 means this is the value of x minus x0. So this is the actually d0 equal to x minus x0, and this. Else when if I not equal to j, then di equal to xi minus xj. Next next loop value of j equal to 1, so I j not equal to I because I equal to 0 here. Next loop j equal to 1, so I equal to 0, j equal to 1. So enter in the else loop, so d0 equal to d0 means x minus x0 into this previous value d0, this is equal to x minus x0 into x0 minus x1. So this is the d value, x minus x0 into x0 minus x1. Next j equal to 2, j equal to 2, so this else loop, so d0 equal to previous value of d0, that is x minus x0 into x0 minus x1 into x0 minus x2. So after completing this j loop, you get this value of d0, these factors, multiplication of these factors d0, you get this after completing this g loop. Next, next loop for I equal to 1. So when I equal to 1, so I equal to 1, that is d1, d1 j equal to 0. So I equal to 0, I equal to 1, j equal to 0. So we enter in the else loop. So d1 equal to uh, d1 previous value, that is d1, initially d1 equal to 1 into x1 minus x0, x1 minus x0, d1 equal to x1 minus x0. So we get the first term of this d1. And so after completing this j loop, I equal to 1, you will get the d1x, you will get the d1x. And in this way, this after completing this all I values I equal to 0, 1, 2, 3, 4, 5, you will get this all d0, d1, d2, d3, d4 and d5. So this is the value this. Now w equal to 1, initial value w equal to 1, and for I equal to g 0, I less than n, up to I less than n, I plus plus, w equal to w star xxk minus xi. So initial value w equal to 1, and the new value of w is equal to 1 into xxk xx0. This is the value of 0.79 plus r plus 1 divided by 100, is x minus x0. So x minus x0, when I equal to 1, this previous w, that is x minus x0 into x minus x1. So x into x x minus x0 into x minus x1, and for I equal to 2, this x minus x0, x minus x1, and for this xk minus xi, that is x minus x2. So this is the wx, this x minus x0, x minus x1, x minus x2, and so on, x minus x5. We calculate this w. So by this loop w, this initially this is the sum equal to 0, and for I loop sum equal to sum plus yi plus di. So when I equal to 0, the previous sum, initial sum is 0. So new sum equal to 0 plus y0 by d0. So y0 is the value of fx. This is y0. This is the y0. This is the y0. That is the fx, first value of fx. This y0. This y0, and this y0 by d0. So sum, initial sum equal to y0 by d0. Next I equal to 1. This previous sum y0 plus d0 plus y1 by d1. Next for I equal to 2, previous sum, that is y0 plus d0 plus y1 by d1 plus, for this yi that is y2 by d2. So by this sum, you will get this the sum of these terms in this square brackets. This y0 plus d0 plus y1 by d1 plus dot dot plus y5 by d5 after completing this I loop. Next, sum equal to w into sum, this w into sum, and this so w means the this w, and this w means x minus x0, x minus x1, x minus x2, and so x minus x5, this w. So this w into sum is the sum is this, that is the square brackets, within square brackets, the terms y0 by d0 plus y1 by d1, and these terms, all these terms. So finally you will get the Lagrange's, actually sum means the here the Lagrange's interpreting polynomial L5x here. So we'll get this wx into sum of this, and this the value of y for the value of x, and this is the for the k equal to 0, that is for x60, first we k equal to 0, we get the first value of x, first for this value x you will get the value of y, and for when k equal to 1, we for this x, xx1, for this x you will get the value of fx. You must delete this portion slash start to start slash, because we write I here write this program part for term by term. This can a integer the interpolating number of points. This and this, you can delete this portion here, which here this less than equal to n. So here the reduced value of n equal to n minus 1. If you want to delete this in, then this remove this equal to I less than equal to only less than I, remove this equal to portion, and this a equal to 0 to 1 is, it is okay. So you if you wish to enter in term by term values of x0 x1 x2 x3 x5 up to x5, and then write this part of this program. And if you wish to write this y0, enter this y0 term by term, then you can write this part of this program of this slash start to start slash, otherwise delete this part of this. So first save this portion, and then compile this, and then run this portion, and enter the value of r. Initially we put here say r equal to 0, the last digit of your serial number, and the required values of fx is this y 0.791 equal to 1.179609, and y 0.979 is equal to 1.385139. Thank you for watching this video, and all C programmings and the explanation notes. These explanation notes these are given in the description box. Thank you again.